Hello everyone, welcome to Physics Meal. Physics Meal is a program under Science Tutorial, and it's a program designed to help students in the study of physics. Then Science Tutorial generally is designed to help students in the study of sciences. Now this edition of Physics Tutorial is a special edition because it is designed for revision. Yes, revision for NECO, SSC, and WASI. That's West African Senior School Certificate Examination. So if you are preparing for this exam, please, you have to try as much as possible to follow us throughout this revision period, and you will not regret it. All right, today on Physics Meal, we are going to revise temperature and its measurement. Because it's revision, we're just going to touch the necessary things that students need to know in each topic. And it will just be an eye-opener so that if there are some parts that you have not actually touched in that particular topic, you now make out time to touch those parts, because our interest is to make sure that you excel in these exams so that you will not go about trying to engage in what is popularly known as expo, because that will actually uh, bring trouble for you if you don't take your time. So that's why we're bringing this revision series to you to prepare you properly for these exams. All right, let's go straight to temperature and its measurement. Temperature is a branch in physics under thermal physics. In physics we have thermal physics where we study about heat and its measurement. That's the principle of calorimetry. So temperature is a part of that particular aspect of physics, that's thermal physics. So quickly we are going to start analyzing some important things that students need to know as far as temperature and its measurement are concerned. So let's begin. First, we need to know the meaning of temperature and maybe other basic terms or basic concepts that are associated with temperature. So what exactly is temperature? You can still remind me that, although you are far away. So as I write the definition, you actually follow me. So we have that temperature is defined as the degree of hotness or coldness of a body. So how hot a body is or how cold a body is what we use to describe the temperature of a body. From time to time, someone can touch you and say your body is hot. Another person may touch you another time and say your body is so cold. The degree of hotness or coldness of a body, that's what we mean by what? Temperature. So the extent of hotness, how hot your body is or how cold your body is, that's what we call temperature. And that's why sometimes somebody may touch your body and say, oh, you are running temperature. Not that temperature is trying to run away from you or that you are running with temperature. It just means that your body is hot. So that's the definition of temperature. We can also define temperature in another way. We say that temperature, can say, or another definition, temperature is a property, precisely a thermodynamic property that determines the direction of heat flow between bodies. So a property that determines the direction of heat flow between bodies is what we call what? Temperature. So temperature is a thermodynamic property that will actually show us the direction of heat flow. So if I have two bodies, I have body A and body B, two different bodies, and heat is to flow from A to B or from B to A, whichever way. We must know the direction the heat is supposed to flow. The only thing that will tell us the direction of heat flow is the temperature. Heat usually flows from a body of higher temperature to a body with what? Lower temperature. So if this body is 60 degrees and this one is 150 degrees centigrade or Celsius, that's one of the scale we are going to consider. So this is 150. Then heat will flow from B to what? A, because B is of a higher what? Temperature. So the temperature now has shown us the direction that heat is supposed to flow. From the knowledge of the temperature, we now know that in this particular system now, heat will not flow from what? From A to B. Rather, heat will flow from B to A. And somebody will ask why? Because B has higher what? Temperature. So you now see that temperature is a property that determines, that shows the direction of heat flow. It is the temperature that will actually tell us the direction in which heat will flow in any given what? System. So heat will usually flow from a body with higher temperature to a body with what? Lower temperature. Very important, so take note of that. Now, the unit of temperature, the SI unit of temperature is Kelvin. Kelvin. So we can say that the SI unit of temperature is Kelvin. It's Kelvin. That's the SI unit of temperature. And the instrument we use in the measurement of temperature is the instrument we call what? Thermometer. The instrument we call thermometer. So thermometer is used in measuring temperature. So when your mother touches your body and say, your body is hot, your mother cannot actually tell us how hot your body is. The only instrument that can tell us how hot or how cold the body is thermometer, because there is no calibration in your mother's hand. We don't have numbers that can actually show us, oh, the body is 30 degrees hot or 50 degrees hot and so on and so forth, because there is no calibration in the hand of your mother. The hand of your mother is not a thermometer. So, but with the aid of a thermometer, I believe you have seen one, with the aid of a thermometer, you can actually measure what? Temperature. So thermometer is used in measuring temperature. Now, there are different temperature scales that we use, so many of them, but there are three that are common. We have the Celsius scale or the centigrade scale. We have the one we call the Fahrenheit scale, and we have the one we call the absolute temperature scale. And that's the Kelvin scale. The Kelvin scale. And that's why you see when we measure temperature, it's either we write it in degrees Celsius or in degrees Fahrenheit or in Kelvin. So any of these. But the SI unit is Kelvin. Is Kelvin. We can still leave some calculation, except you are asked to change to Kelvin. We usually leave our calculation in Celsius. That's what is common as far as the exam you're about to write is concerned. Kelvin is usually a must whenever we are dealing with the laws of gases. That's the general gas equation, the Charles law in chemistry, the pressure law also. We must convert the temperature to what? To Kelvin. It is a must. It's a must under those circumstances. So, but when we have temperature in Celsius, unless stated otherwise, we still leave our answers in Celsius when we are doing calculations in physics, except when you are talking about the gas laws. All right. So we have the Celsius scale, the Fahrenheit scale, and the what? Absolute temperature. So these are the three common temperature scale. We have what we call the Rankine, but we will not be considering Rankine at this level. So we just need to know these three. We are still going to look at the relationship between these three temperature scales. We're going to look at the relationship between these temperature scale. But there is need for us to talk about a little about thermometer, especially as it concerns the calibration of what? Of a thermometer. Now, if you have a thermometer, the numbers, there must be numbers. Let's just say that this is a thermometer. Let's just say this is a thermometer. Now, the thermometer have to be calibrated or graduated. Calibrated, in other words, numbers need to be indicated here. This is 0 and so on and so forth. We have marks. And maybe here is 100, so on, maybe in degrees Celsius. So here is 0, here 100. So the question is this: how do we actually calibrate these thermometers? How do we calibrate thermometers? How do we fix this point? How do we get this point? There are 2 points that need to be fixed, 2 important points that we must consider in calibration of temperature. One of the points is what we call the lower fix point, and the other point is the what? Upper fix point. So there are 2 points necessary in the calibration of thermometer. We are still going to link these 2 points with this temperature scale when we now want to show relationship between the temperature scale. So to calibrate a thermometer, there are 2 points that must be fixed. There are 2 points that must be fixed. And what are these 2 points that must be fixed? We say the points are lower fix point and the upper fixed point. The lower fixed point and the what? Upper fixed what? Point. That's the 2 points that we need to fix in order to calibrate the thermometer. So what do we mean by lower fixed point? What do we mean by lower fixed point? Lower fixed point of a thermometer is the temperature of melting ice. The temperature of melting ice. Thus, the lower fixed point is 0 degrees. Okay. Then we need to talk about upper fixed points also. The upper fixed points. We can now say, what is upper fixed point? Upper fixed point of a thermometer is the temperature of water boiling at normal atmospheric pressure. Thus, the upper fixed point is 100 degrees. Okay, 100 degrees Celsius. That's the upper fixed point. 100 degrees centigrade or Celsius. So the lower fixed point is the temperature of melting ice. You know ice, the solid form of water. Thus the lower fixed point is 0 degrees. You remember that the melting point of ice is 0 degrees. Now the upper fixed point is the temperature of water boiling at what? Normal atmospheric pressure. And the boiling point of water is 100 degrees. So the lower fixed point is 0 degrees and the upper fixed point is what? 100 what? Degrees. Lower fixed point is 0 degrees and the upper fixed point is what? 100 degrees. Very important. Very important. Okay. Now, there is a special instrument we normally use in the determination of upper upper fixed point, they call it hypsometer. We'll not go into those experiments because this is a revision series, but when you have your standard textbook, General Certificate Physics by Abbott, you also talk about the New School Physics, you can actually consult them as you are looking at this, watching these revision classes. You verify some things, the hypsometer, know the diagram of the hypsometer. In case maybe they ask you to describe an experiment to determine what? To determine the upper fixed point of a thermometer. So that's the essence of this revision, so that you now know the areas that you may likely touch. Because we want you to study constantly. After school, you watch some of these videos to actually get so familiar with them that you will not forget anything. All right, so we have a special instrument we call the hypsometer, whichever one, know the spelling. This is not a phonetics class, so know the spelling. That's the most important thing. All right, now the distance between the upper fixed point and the lower fixed point is what we call the fundamental interval. So if you have a thermometer now, if this is a thermometer, and here is 100 degrees, that's the upper fixed point, and here is what? Let me write this here. I believe you now know hypsometer. Let me write it again here, so I can use this part of the board. Okay. Now, if this is a thermometer, let's take this as a thermometer. If this is the upper fixed point, 100 degrees C, and here is the lower fixed point. Lower fixed point, 0 degrees. Now, the difference or the distance between the upper fixed point and the lower fixed point is what we call the fundamental interval. The fundamental interval is the distance between the upper fixed point and the lower fixed point. So we need to take note of that. We need to take note of that. The fundamental interval. So we say the distance between, or the difference between the upper fixed point and lower fixed point is known as the fundamental interval. It's known as the fundamental interval. The difference between the upper fixed point and the lower fixed point, that's the fundamental interval. Now, the fundamental intervals vary from temperature scale to temperature scale. From here now, this is the Celsius scale. You now discover that the fundamental interval will just be 100 minus 0, which is 100. But the fundamental interval for Fahrenheit scale now will not be what? 100, because the upper fixed point and the lower fixed point are different from that of what? That of the Celsius scale. So we are going to see the fundamental interval for the other two temperature scales apart from the Celsius. So let's just drop a table. The table below which show us the fundamental interval of this. Now let's say this is the temperature scale. We have a temperature scale. Okay, now that we have the upper fixed point. We have upper fixed point. We have lower fixed point, and then we have the fundamental interval. So let's just put these three of them. Okay, I still have some spaces here. So the first is the centigrade or the Celsius degree degrees Celsius. The other one is the Fahrenheit. In degrees Fahrenheit. Let me put the unit here, just for space. And the other one is absolute temperature in Kelvin. Now, the upper fixed point here is 100 degrees. The lower fixed point is 0. And then the fundamental interval is difference between this, and that will give me what? 100. Now, for Fahrenheit, the upper fixed point is 212. The lower fixed point is 32. And the fundamental interval is 180. Absolute temperature, upper fixed point is 373, lower fixed point 273, and the fundamental interval is going to give us still 100. Still 100. All right. That's it. So this table shows us the upper fixed point, the lower fixed point, and the fundamental interval for each of the temperature scale that we have considered. Now, with this, we can actually establish relationships between the upper fixed point, these temperature scales. We can establish relationship between these temperature scales. So, between temperature scales. We can actually talk about, just this revision class, let's talk about Celsius quickly, Celsius and Fahrenheit. Let's talk about Celsius and Fahrenheit. That's this and this. Now, all we need to do is to draw a diagram, a figure. We have this. Let's be the degree Celsius and this be the Fahrenheit. So let's have that. Let any temperature here be C, and this one is the upper fixed point 100, and this one is 0. Then this is upper fixed point of 212. Then let any other temperature be F, and this one is actually 32. So if we check this, we do a sort of interpolation, and we are going to have this, that C minus 0, that this minus the lower fixed point, all upon the upper fixed point minus the lower fixed point. The ratio will always be equal when you compare two temperature scales. Now this will give me F minus the lower fixed point, which is 32, all upon 212 minus 32. Okay, that will give us C over 100 equals F minus 32 over 180. That's what we are going to have. C over 100 all upon this. So this is the relationship that exists between C and the what? And the F. I can go further. Let's go further. If you multiply both sides, this is mathematics now. If you multiply both sides by 180, or maybe you do your cross multiplication, you're going to have 180C is what? 100 bracket F minus 32. That's what you have. Divide both sides by 100. If you divide both sides by 100, it means I will divide this by 100, divide this by 100. So 100 divided this will give me 1.8C equals F minus 32. We will not. So the important thing why we have to do this is so that you know how it's derived, in case you just forget. Now we'll look at this. In case you forgot how you obtain this, maybe you forgot the formula, you can actually derive it again. So from here, if we make F the subject, we have F to be 1.8C plus 32. Now this is the relationship that exists between the Fahrenheit and the what? And the Celsius scale. That's the relationship that exists between them. So if someone gives me a value, maybe you are giving a value, maybe you're told that change 30 degrees C to Fahrenheit, 30 degrees C. So the temperature now in Celsius is 30 degrees. All you need to do is to substitute it here. You get your answer F will now give you 1.8 times 30 plus 32. When you multiply this first, because applying mathematics, this is no longer physics. Physics has just ended. 30 times this, we are going to have 54 plus 32. 54 plus 32 will give us 86 degrees. So 30 degrees in Celsius, sorry, it's Fahrenheit now. 30 degrees in centigrade or Celsius is equivalent to what? 86 degrees what? Fahrenheit. It's equivalent to it. It's equivalent. Okay. Now, the same way you can actually obtain the relationship between Kelvin, the Kelvin scale, that's the absolute temperature scale, absolute temperature, and the Celsius scale. We just quote that temperature in Kelvin, where K is in Kelvin, is 273 plus temperature in degrees what? Celsius. So when I add 273 and temperature in degrees Celsius, I will have temperature in Kelvin. You see that? Where K, now we are using K to represent temperature in what? In Kelvin. That's the absolute temperature. And this temperature in degrees Celsius. So similar way, if they now say find, convert, or find the absolute temperature equivalent of, let's say, 25 degrees C. Very simple. We can do that. The absolute temperature equivalent K will be 273 plus what is C now, this plus 25. That will give us what? 298. Beautiful enough. All right. We're going to go for a short break because this is a revision class, so we need to give you some space to relax, and then we continue with the revision. We're going to go for a short break, and when we return, we are still on the concept of temperature and its measurement. Is a revision series for this particular topic. So take your time, go through this video over and over again until you have grabbed everything that you need to grab. Yes, it's very, very important. Just pick all the things that you need to pick. Very, very important. Very, very important. Because we don't want you to fail your exam. We want you to excel. And excel honorably, not excelling with, you know, some wayo or some other means that are not legitimate. So we want you to excel honorably, so that whatsoever thing grade you are able to obtain is a grade that you can actually defend, not a grade that you will not be able to defend. So when we come back, we're going to continue with the concept of temperature and its measurement in this revision work series. And we are going to look at some types of thermometer. We're going to look at types of thermometer and also see some mathematical expressions that will help us to do calculations in relation with types of what? Thermometer. Thank you, and God bless you.